Hello viewers, welcome to MSS Television. Today on the Top Brain Show, we are going to tackle a question on integration. I am your peer teacher, Mercy Wanjiru. Welcome. And here is the question. A particle was moving along a straight line. The acceleration of the particle after t seconds was given by 9 minus 3t into bracket meters per second squared. The initial velocity of the particle was 7 meters per second. Find A. The velocity v of the particle at any given time. B. The maximum velocity of the particle. C. The distance covered by the particle by the time it attained maximum velocity. And this is how we solve the question. We are required to find the velocity v of the particle at any given time, and in our question we have been given the acceleration as, in part A now, acceleration is equals to 9 minus 3t into brackets meters per second squared. We are supposed to find the velocity of this, so we are supposed to integrate this one. It will become 9t minus 3t squared, you divide by 2 plus the constant. And we are told that the initial velocity of the particle was 7 meters per second. The initial one is this, so we replace 7 is equals to 9t minus 3 over 2 t squared plus the constant which we don't know. And we know the initial velocity, it's when time is equals to 0. So we substitute in the equation. It will become 7 is equals to 9 multiplied by 0 into brackets minus 3 over 2 times 0 into this squared into bracket plus the constant which we don't know. It will become 7 is equals to 0 minus 0 plus c. So the constant will be 7. Therefore, the velocity will be 9t minus 3 over 2t squared plus 7. And that's the answer in part A. On to part B, the question requires us to find the maximum velocity of the particle. And we know that when we are told the maximum velocity, it's when the acceleration is equals to 0. So we go about to our question where we were told acceleration is equals to 9 minus 3t into brackets meters per second square. The acceleration is 0 is equals to 9 minus 3t. This 9 will go to the other side and it will become negative 9 is equals to negative 3t. We are supposed to remain with t alone, so we divide by negative 3 and here negative 3. This will go with this and this. We remain by 1 and here 3. 3, 1, 3, 1. So our t is equals to 3. And we know that the velocity is equals to 9t minus 3 over 2 t squared plus 7. We substitute these 3 to the equation. So velocity is equals to 9 times 3 into brackets minus 3 over 2 3 squared plus 7, and we get the velocity as 27 minus 13.5 plus 7. So the maximum velocity of the particle was 20.5 or 20.5 meters per second. That's the answer in part B. And on to part C, we are required to find the distance covered by the particle by the time it attained maximum velocity. And we know that velocity is equals to 9t minus 3 over 2t squared plus 7. And we know that when you want to find the distance, you integrate the velocity. So the distance is equals to 9t squared, you divide by 2, minus 3/2 divided by 3t cubed plus 7t. And we shall get the distance is equals to 4.5t squared minus 0.5t cubed plus 7t. And we know that when maximum velocity, we already got t as 3. So we come and substitute in the equation. Distance, it will be 4.5t times 3 squared into brackets minus 0.5t, which is 3 cubed, plus 7 times 3. And we get the distance as 40.5 minus 13.5 plus 21. So the distance will be 48 meters, which is our answer on part C. And that marks the end of our lesson today. I hope you have understood. Don't forget to subscribe to MSS Television on YouTube. Until next time, bye-bye.